The next student speaker is a student of Dr. Casey Garante's physics course. This is the physics of horseback riding. Please come to the podium, Ms. Ameena Arekat.
My name is Ameena Arekat, and I will be talking about the physics involved with horseback riding. Just an overview of what I will be talking about today. We'll first start off with what is horseback riding. Then I will move on to the gaits of the horse, as well as the posting trot. Then I will go into Newton's laws of motion, energy, torque, and the famous racehorse Secretariat, and how his stride length helped him win the Triple Crown. Here's a picture of the 2015 Kentucky Derby. It was just a few weeks ago, and I wanted to put this picture in here to show you and to help my presentation. I want you to take a look at the stride lengths of each horse. American Pharaoh is number 18. He's in the lead, and he won by just a length. A length is about 8 feet, so he won just a little under it. If you can see that the other horse behind him, firing line is a little bit in front of his tail. So keep this picture in mind. I'll revisit this later in the presentation. What is horsepower? Horsepower is a unit of power, and it was first conducted or created by engineer James Watt, and he conducted experiments with draft horses in the 18th century. What he did was he found that through draft horses produced a large amounts of power and work throughout the day, and he discovered that they were able to conduct 50% more power, or 1.5 more times power than the average horse. So this is a pretty large amount of power that just one animal can conduct, and it was pretty awesome that he was able to conduct this. The gaits of the horse. For the next few parts, I'm going to teach you about the gaits of the horse. There's 4 different gaits. Obviously the walk is the slowest. Next is the trot, then the canter and the lope are synonymous terms with each other. And finally the gallop. The trot is a 2-beat gait, and it is the most comfortable for the horse because it is at least 2 of their hooves are on the ground at the same time, so they have the most balance at this gait. Since their head and neck weigh about 50 to 70% of their total weight, being able to move that large amount of weight up and down allows them to have more balance. The average velocity for the horse at the trot is about 13 kilometers an hour, so it's not that fast, but it is pretty bumpy. The canter is a 3-beat gait, and this is when the horse has a leading side. So this is also the same as like a dog. If you watch them run, you'll see that either their left side or the right side is leading. This is the same with the horse. Either their left 2 legs are leading, or their right 2 legs are leading. The last gait is the gallop, and this is just the expansion of the lope. This is about the average speed for that is about 40 to 48 kilometers an hour, so it's a little faster than the trot or the lope. Back to the trot, you can either sit with the trot or you can post with the trot. Posting trot is more relevant to physics because the rider has to rise and fall with each step of the horse. So this allows the rider to be more comfortable and be more in rhythm with the horse. And this, obviously there is some work done because the rider is technically squatting as they're riding. So you can compute the amount of work done by the rider by multiplying the weight of the rider times the length of the displacement the rider travels upward from the saddle. So, and that will be given in units of joules. Next is Newton's laws of motion. He has 3 laws. The first law is an object in motion will stay in motion unless an outside force acts upon it. An example of this is when a horse is preparing to jump over an obstacle. The horse obviously has to conduct enough energy and power to force himself over the jump. So this is that change in force. Newton's second law deals with acceleration. And his law is an acceleration of an object produced by a net force that is directly proportional to the magnitude of and in the same direction of the net force. So pretty much what he's saying here, an example, is that the horse has to have enough, there has to be enough change in force and acceleration in order for the horse to jump over the obstacle. If he does not have enough force, the acceleration and enough acceleration, then the horse will not be able to jump over the obstacle, and he will probably run into the obstacle and he won't complete the jump. Newton's third law is for every action there is an equal and opposite reaction. An example of this is when the horse again is about to take off from the jump. As you can see from the picture, its back 2 legs are on the ground, or hooves are on the ground, and they're helping him propel or push the horse up over the jump. So this means that the hooves are producing a force directly onto the ground, pushing down onto the ground. But the ground also has to produce an opposite force in the same magnitude as the hooves do. So if the ground does not produce that same opposite force pushing upwards, then the horse will just sink and won't be able to jump. Next is energy. There's 2 types of energy that I could talk about, but kinetic energy is the most relevant to this. Kinetic energy is an object's energy it possesses when it's in motion. So, for example, the horse is running on the track in Kentucky Derby. They possess kinetic energy because they are running. This can be found, the amount of kinetic energy can be found by multiplying the mass of the horse times its velocity squared, and then multiplying all of that number by a half. And that unit is in joules, so it's a unit of power. Torque is the measure of the force applied that causes an object to rotate about its axis. The point of axis for the horse is in the back 2 legs at the horse's hocks. The horse's hock is circled there, and it is equivalent to the human's knee or ankle, and this is the horse's point of axis. So when the horse is running around and completing tight turns, the most amount of torque is found on the hocks. So, for example, if you are running a barrel racing pattern, which is a rodeo sport, you go around, you make 3 turns as tight as you can and as fast as you can, and the horse, in order for the horse to turn well and tight enough, it has to rely on its hocks. So obviously it's rotating about its hocks around that barrel, so you'll find the most amount of torque on the hocks. Back to horse racing. Secretariat is probably the most well-known racehorse, just since his Triple Crown win back in 1973. He was able to win the Belmont Stakes, which is the last 3 of the races, in the 3 races, the Kentucky Derby, Preakness Stakes, and Belmont Stakes. The Belmont Stakes, he was able to win that in about 2 minutes and 24 seconds, which is a track record. But how does horse racing relate to physics? Well, if you look at Secretariat's stride angle, and stride angle is defined as the maximum opening between the front and rear legs. So if you look at his stride angle, it is about 110 degrees. So and an important fact here is that for every degree that is increased in the stride angle, the stride length is increased by 2%. So if you increase the stride angle by 10 degrees, you will cover about 20% more ground with each stride. So if you compare the angle of Secretariat to the angle of a cheetah, and that's 125 degrees, the cheetah has a top speed of 70 miles per hour, whereas Secretariat's was only 49 miles per hour. So why is there such a big difference? Microfibers are the answer. Microfibers are or scar tissue. It surrounds the muscles of the legs, and it contributes to the stride angle. So these microfibers are are created after there's stress or injury on the muscle, and just like a cast, when you break your arm, it immobilizes that muscle or that area where there's injury. And with this, it shortens the stride length. So this then results in a decrease in speed. So assuming that Secretariat did not have these microfibers, his stride angle would have been that much larger, and his top speed would have been that much greater. And here is a video of Secretariat winning the Belmont Stakes, which is the last 3 of the races. In the Triple Crown, I apologize for the resolution. It was back in 1973, so they did not have very good high-tech technology. Each length is again about 8 feet, and that just shows how fast he ran. Of course, you probably heard that his heart was about 2.5 times the size of an average horse's heart, so that also contributed to it. But if his heart was in that great of a health, then we could assume that he did have those microfibers to restrict his stride angle. In conclusion, the main inspiration for this is my horse, and she was able to help me, when I went out riding, she was able to help me figure out, okay, what could I talk about with this? How is physics really related to horseback riding? And it just shows that physics is involved with everything that we do, and it was really interesting about the microfibers. I found that really interesting that it could have that much of an effect on the horse racing. Newton's laws of motion, energy, torque are all related in some way or another, and if we have a better understanding and increase technology, then who knows, maybe we could decrease the amount of microfibers, and the next Triple Crown winner could win more than 25 lengths. Thank you. Are there any questions? Yes.
Sorry, I have a question again. But the scar tissue or microfibers, when you massage your horse, does that help with decreasing the amount of scar tissue?
I did not research that part, but I would assume that just with my knowledge of my other classes, that probably would help. And I'm guessing that with the increases in science and understanding of medicines, that they would probably have something to help loosen up those fibers as well. Anybody else?
What's the difference between a draft horse and a regular horse other than it's stronger?
So a draft horse is equivalent to, it's on the same size as a Budweiser Clydesdale, those really large horses. So those are mostly used those are work horses. They were used in farms when we didn't have tractors or things like that to plow stuff. So those are fairly large horses. The average horse is about 1,100 to 1,200 pounds, whereas those draft horses are about probably closer to 2,000, and they just are bulkier and consistent more work. Anybody else? Thank you.